I just want to also, on behalf of the board, extend my welcome to everyone who's here. It's going to be a very intellectually challenging and exciting week. So with that, one of the themes that you're going to hear throughout the three keynotes this morning is around innovation. And I think if you think about innovation, it's this unique blend of science and engineering, but also creativity, ambition, and courage. And that takes a special culture, and we're lucky in HP Labs to have a leader who joined us 4 years ago who's brought that kind of culture into our research organization. Dr. Prith Banerjee, before being the Senior Vice President for Research at HP, had a very prominent position as the Dean of College and Engineering at the University of Illinois. Prior to that, he was the Dean of the Computer Science Department at Northwestern University. His contributions have been recognized in many different forums nationally. He's one of the few people I know that's both a fellow of IEEE, a fellow of ACM, as well as a fellow of the American Association of the Advancement of Science. He received one of the very first presidential Young Investigator Awards back in 1987, and somewhere in his spare time he started 2 companies. So Prith is a passionate person who believes strongly in innovation. It's my honor to introduce him, and so with our next keynote, Dr. Prith Banerjee. Prith?
Thank you. Good morning. Thank you, Rich. Thank you, Chris, for inviting me. And it's a pleasure to be here today talking about everything as a service powering the information economy. I couldn't have asked for a better introduction to the topic than from my very established colleague, from a gentleman from IBM who I have known many years. IBM has done a lot of excellent work in the services research, and he provided a great background to the problems that we are working on. So I would like to take a kind of follow-up on the conversations that Robert talked about. We are in the information economy. There is a lot of information being generated in the structured world and the unstructured world. And if you look at the amount of data that is being generated today, 80% of the data is actually unstructured data. So the question is, when you get all this data, some from your sort of structured data from your databases, unstructured data from your Facebook updates and tweets and from sensors, and you're trying to pull it all together, you have to bring the context of the information sort of search to solve that problem. All these, the computations and so on that you do to extract value from the information is essentially going to happen from the cloud, but when you are interacting with this information, you will do it through a set of mobile devices. And it's not the number of mobile devices that you have, right? It's such a large variety of devices, your smartphones, your touchpad, your laptop, your workstations, and so on. So what you need to do is to provide a seamless experience across these multiple endpoints, a secure connection to all these sort of billions of devices that you have and the trillions of sensors, and to make this information extraction be context aware. So our CEO, Leo Apotheker, on March 14th, discussed an HP strategy with various analysts and so on. And I wanted to share with you our vision of where this industry is headed. It's around a seamless, secure, connected experience, a context-aware experiences in the connected world of this information economy. And what I'm going to do is talk about some of the exciting work going on at HP Labs, which is aligned with this strategy for our customers. Now, there are two worlds that are kind of blurring today. The personal world, the kinds of things that we do on Facebook and tweets and so on and so forth, and the professional world, the world of businesses. And you may wish to do these in 2 different devices, 2 different workstations, 2 different whatever, because of security reasons. That is not the way it's going to happen. The world is moving towards a seamless experience of the private personal world and the professional world, the seamless experience across the multiple set of devices, and you need to do that in a very, very secure yet context-aware world. That's the framework of our conversation. But before I go into the research, I want to talk about two trends that you are all probably seeing: the trend of connectivity and the trend of cloud. So as you look at connectivity, when we use our smartphones and touchpads and multiple devices, we expect to be connected all the time. I can guarantee you that as all of you are sitting in the audience, you are probably checking your email, you're checking your tweets and so on, and probably checking the score of India versus Pakistan in cricket. I also checked it. So we are in this world of always trying to be connected to the world of information. And you expect it. So if you look at the mobile connected world, it's a world that will have the 6 billion people on Earth, 4 billion people will be connected through these mobile devices. It's a tremendous opportunity. In the future, there'll be 10 billion units that will be connected together with a large business, part of which will be generated through advertising, part of which will be generated through value-added services in the range of $40 billion. It's a very, very significant transformation that is going around today. The second is the cloud. Industry is moving towards everything being offered as a service instead of owning your own IT infrastructure, your own servers, your own storage, your own computing, and so on. You would like to pay for it as you go from the cloud. So this cloud computing area is a very, very significant transformation, and people are moving to higher and higher levels of the stack. And we need to look at how the services industry will be transformed by this technology of cloud computing. It's a very, very big business in the range of $150 billion in the next several years. So now you bring them both together, cloud and connectivity. Everything will be provided as a service. The computation services will happen on the cloud, but you'll access them through these seamless experiences across the multiple devices that you own. And you need to be always connected. So our CEO, when he talked to the analysts, talked about the opportunity that is available for HP's customers. Cloud and connectivity are being brought together by the large set of devices at the touch points. HP today interacts with its customers using the PCs and workstations and laptops and so on through about 50 million plus devices. It also interacts with customers every year with 50 million printer devices. So if each of them can have the same seamless experience, that's a way to connect with a lot of people who can access various services from the cloud, from both the personal world and the professional world in a secure, context-aware manner. So I want to provide a point of view from an HP Labs perspective as to how this world of everything as a service will be delivered to customers both in the professional world and in the personal consumer world through multiple levels of a stack. At the lowest level, consumers are already accessing services through the public cloud, through the likes of Amazon Web Services. Yet, there is a perception that those services may not be as secure as you expect in an enterprise setting. And therefore, there's kind of two worlds out there in providing infrastructure as a service: the private cloud for enterprise customers and the public cloud for the consumers. And that's changing, and essentially, there is going to be a hybridization of the public cloud and the private cloud. And there's a lot of work that needs to be done in making this a seamless experience and a very, very secure experience. Moving up, there is a need for developing platform services on the cloud. And what's a platform? Essentially, if you have to just use compute as a service, you have a bare bones infrastructure. You essentially don't have a lot of tools to allow you to build applications on top of that service. So on top of platform, you need sort of tools to help you build applications, tools to help you test applications, tools to have you operate applications in this cloud environment. You put it all together, that becomes a platform, and that's sort of platform as a service. Move it up a higher level, you develop entire applications as a service, the kinds of applications that Robert talked about in the healthcare area, in transportation, in energy, and so on and so forth. So you can build entire software applications on the cloud, on top of a platform, running on top of an infrastructure. Now, many of us download applications for our variety of devices that we have, those iPhone apps on iPhones and the Android apps on the Android ecosystem. So there's a bunch of ecosystems out there in the consumer world. Wouldn't it be nice to have a similar set of apps that you could download on a set of devices that allow you to have consumer apps and enterprise apps on the same device that will allow you to transition smoothly from your consumer applications to the professional applications? As it turns out, oftentimes the kinds of things that we do touch both worlds. And so our vision is to create a platform, an open cloud marketplace, and some of the work that is going on at Labs is focused on that area, to allow you to say that when I say that I'm sick, right, I'm probably entering some things, tweeting to my friends that my body temperature has gone up and so on, and then if I can pull that data, as Robert mentioned, right, and make it available to the professionals, and essentially now you have gone into the enterprise cloud for a Kaiser Permanente system. So essentially, if you can create, and that is a kind of a problem for all the scientists out here, right, an open cloud marketplace that will allow people to have consumer applications, enterprise applications, both for the public and private cloud and for the hybrid cloud. It is a very, very hard problem, right? But I think this research community can actually work on that. And ultimately, all these services will be access to a multiple set of touch points, the smartphones, the tablets, the PCs, the printers, and so on and so forth. So that's kind of the vision that we are working on. Now, at HP Labs, we are working on sort of, obviously, in terms of research, with a central research arm for Hewlett-Packard, we are trying to work on breakthrough technologies in each of these areas, where we are trying to advance the state of the art and provide business opportunities for the mothership, right? So we would like to give you a quick overview of the research areas that HP Labs scientists are working on, and many of the scientists are actually here today. There are 8 themes, there's 7 labs, and there are 8 themes of research that we are at this point currently exploring. One is in the area of cloud and security, and essentially what we are working on is this end state of lots and lots of services, millions of services being available to billions of users in the world, right, through tens of thousands of servers and sending petabytes of data across large networks. How do you do that in a context-aware manner, in a seamless, secure manner? We have work going on in the mobile and immersive experiences, where essentially there's a work going on these connected endpoints, those touch points, and the new forms of interfaces, interactions that you can have beyond the keyboard, beyond the touch, using gestures and 3D and newer forms of context-aware ways to interact with the technology to the cloud, but with a set of mobile devices. Our work on information analytics is on trying to do deep analytics on both structured and unstructured data, the kinds of things that Robert mentioned. And essentially, if you can pull the data from all the noisy data that you have from this sort of billions of tweets that are going out there, and try to find the meaning behind this information. How do you categorize? How do you extract information? How do you create metadata on the information and run appropriate processes around governance and e-discovery and policies and so on? To drive the next generation of server, storage, networking for the cloud, you need to do deep work on what we call intelligent infrastructure. So there's a lot of work going on in scalable storage architectures, scalable networks, scalable a central nervous system from the earth, connections, connecting trillions of sensors together and providing higher level information to various customers in the enterprise domain and in the consumer domain. Finally, we have work going on in the services area in terms of providing higher value services by leveraging technology and making it using deep analytics to make your experience a lot more personal. And Jamie is going to actually be in a panel following this, and she'll go into a lot more detail about the work going on in services. Ultimately, there is a theme on sustainability, and this has to do with trying to reduce the energy consumption, reducing the carbon footprint in the world, and we have a lot of work going on in the area of sustainability. Let me now talk about some of the work that is needed to be solved in providing this everything as a service vision for powering the information economy. It involves, at the lowest level, infrastructure as a service, the next higher level, platform as a service, and the highest level, software as a service. So I'll talk briefly about some of the research that is going on in each of these areas. In the area of infrastructure as a service, we have work going on in scalable storage, in efficient computer infrastructures, and on sustainable data centers. So as we are facing this information explosion problem, right, where the amount of digital information is doubling every 18 months, we have just so much information. People want to store this information cheaply, scalably, and reliably. So the problem that we face is, can we come up with a highly scalable storage architecture that can store data at large scale in multiple locations, so between 2 to 100 data centers, lots and lots of data, 1 exabyte of data. You want to do that in a very highly available manner so that you can actually access the data when you need it at 99.99% reliability and do it at low cost. So it turns out that the world knows how to do 2 of these things simultaneously. You can do at large scale, high availability, but it's going to cost you a ton of money. Or you can do large scale, low cost, it will fail all the time. So the question is, how do you do all 3 things simultaneously? So the technology that has been developed at HP Labs is on a system level coding technology called Erasure Codes, and I will not go into the details of the technology. We have a paper in IEEE Computer Magazine in the March issue, which goes into some of the details of the technology that I'm going to talk about today. But it involves erasure coding, which is a better way of providing high availability at lower cost than the traditional ways that are used in the cloud data centers today, which is triplication. Looks like, so the way erasure coding works is with on this example, with 8 data segments, you add 4 data segments, you add 8 parity segments, and you can do better availability than simple triplication. So using this erasure coding, we have been able to implement a system called key value store, which is a way to provide an interface to storing large amounts of data with this get and put forms, and essentially do this in a highly available manner through clients can make calls to do gets and puts anywhere, and they will go to various proxy servers. The proxy servers send their request to fragment sector servers who do the appropriate data lookup of the higher level metadata and provide the data back to the user in a highly available, low cost, and scalable manner. The next work is on our work on energy efficient computer infrastructures, and the work here is try to look at the future as to where a data-centric, a web-centric server is headed. Today the servers that you see use fairly high performance CPUs, connect a bunch of high performance CPUs together, lots of memory, and that is driving all the Web 2.2 applications. Requires a lot of energy consumption, not as scalable as you want them to be. So what we have been working on is the concept of micro blades and mega servers, where you put a large number of very, very low power CPUs from the embedded world, such as ARM and others, and you build up micro blades based on them and memory blades and a lot of these things connected together with new forms and power and cooling to build up these sort of data centers, server architectures of the future, using which we have been able to show through simulation experiences that you can get very significant performance over power consumption, significantly over the kinds of architectures that you see today. So there's a lot of work in those kind of next generation server architectures. To drive these server architectures, we have got work going on in changing the way you store content in memory. Instead of using the traditional forms of memory, which is the DRAMs, the level 1 caches, level 2 caches, DRAMs, flash memory, and disk drives, we at HP Labs are thinking of a future where the entire memory architecture will be replaced by these non-volatile memory called memristors, and you tie these together, and you have 3D stacked non-volatile memory, these memristors, connected with low-power processors, a large number of low-power processors, connected through photonic interconnects, and that is the fundamental architecture of a thing called a nanostore, and that will be the building block for the servers in the future. When you look at data centers today, they consume a lot of power, a lot of energy. So you need to bring down the energy consumption in data centers. Turns out that there's a very interesting approach that you can take, and the approach taken at HP Labs is that of a net zero data center. If you look at holistically at the design of data centers and how data centers are operated, there are different ways you can control this by looking at the supply side and the demand side. So the supply side is look at energy consumption. Well, you have supply from the power grid. You can have supply from solar, from biofuels, from farm waste, and so on and so forth. There's multiple ways you can actually source power. Depending on the time of the day, you can do solar power or whatever. And then you can also control the demand by appropriately positioning your processes, the virtual machines on different processors. You can shut down other processors and therefore reduce the cooling. So what we are working on is a net zero energy cost, energy consumption in these future sustainable data centers. Using the kinds of technologies done by our researchers at labs, we have been able to show that if you look at the energy use in a typical data center, if you do use our energy, our supply demand side reduction of energy, the energy consumption goes down significantly with a 48% reduction in the total cost of ownership. And if you look at the total energy reduced in a typical data center and multiply it over all the data centers in the world, over the next 3 years, a study was done which showed that the energy consumption would be reduced by 650,000 terajoules, which is the energy consumed by a country the size of Peru. So very, very significant opportunities in energy reduction in these large data centers, which is needed in order to solve the energy consumption problem. The next thing I want to talk about is our work on platform as a service. And here, what we are building is a way to allow people to have multiple applications running on the cloud, and yet these applications not being able to, there should be no security holes in these multi-tenanted applications. And when you're doing IT management, you can have one set of applications running on the cloud. If that takes a lot of computing resources and storage resources, it can actually impact the performance of other applications. You want to provide very, very secure boundaries, so one application cannot impact the security and the performance of any other application. We have done that with the use of a technology called cells as a service, where essentially what you do is you create virtual compute cells and virtual storage cells, and you connect them together. And through this very, very secure way of creating virtual cells, compute cells, and storage cells, you make sure that the applications cannot hurt each other, cannot have performance impacts on each other. And there's a lot of technologies on a virtualized distributed data routing that allows these computations to talk to each other at very high performance if they need to, and they cannot talk if they are not supposed to. So that's kind of the basis of the technology in cells as a service. At the next higher level, we have a lot of work going on in software as a service, and the kind of, as I'm moving up the stack, so this particular work tries to bring in the large amounts of information that is being generated through this sort of 80% unstructured data and the 20% structured data. And what kind of new services can we build? So fundamentally, what we are sort of facing is an information explosion problem, right? And how do you solve this economics of attention problem? So you look at a front page of the New York Times. The editor of the New York Times is making some judgment as to what news articles should appear on the front page of New York Times, right? There's just tens of thousands of news articles being spewed by Reuters and API and so on and so forth. And the New York Times editor makes a judgment as to what are the most important 30 news articles that will go on there. When you look at a web page of any company, there is an amount of information that is reflected on the web page at a given time, so you can see it on your laptop, your workstation, or your touchpad, or your smartphone. So there is a lot of very interesting research that can be done, is being done on this economics of attention, which is trying to trade off the popularity of this news versus the relevance of the news, the recency of the news. It turns out that there are news items like the earthquake in Japan, which is so important, it still continues to be relevant today. And then there is maybe a news about some auto accident that's just happened on the freeway right now, and you want to show that. So that's that latest breaking news. The question is, how do you actually solve this problem of economics of attention? So there is some work going on at HP Labs on eye catcher that addresses this particular issue. When you look at a lot of data, right, on this in the unstructured form, there's a lot of sort of noise that is going around in the world. Can you try to probe all this, monitor all this noisy data, and do higher level information? So there's a work that was done at HP Labs on monitoring tweets of people talking about movies before a movie gets released. So it turns out, before a movie gets released, Hollywood would love to know the projected revenue, because based on this, they can plan the number of theaters they will go to, the number of screenings, and so on. Turns out that many of us actually tweet about the fact that, oh, I'm going to go watch the movie, or no, I'm not going to watch the movie. So just by monitoring the tweets and the frequency of tweets, you can actually predict how good this movie will be doing, and we showed that in that area. We have done monitoring of customer sentiments to look at, for example, how a hotel's performance is going, right, at a particular instance. Suppose you check into a hotel and you have had not so good experience. After you have gone out of the hotel, potentially you may go into TripAdvisor on a scale of 1 to 5. You can say, this hotel was ranked 4, or this hotel was ranked 2. Or you can fill up a paper survey and you say, well, this is the kind of hotel experience I got. People don't have time for filling up paper surveys. People don't have time to go onto websites and fill up on a scale of 1 to 5 the rating of a hotel. However, the current generation of people, right, they are tweeting all the time. So as soon as they have entered into the room of a hotel, if the carpet is dirty, they may tweet, the hotel room in the carpet in this hotel room was dirty. or the service attendant was rude. The food was cold. So people are tweeting all the time, right? So if we could monitor all these tweets and look at the sentiment, is it a positive thing that is being said or a negative thing that is being said, you could actually create what we call live customer intelligence on all these millions and billions of signals that you're getting, these noisy signals that Robert talked about. Now, all these things that I talked about, right, and there are literally loads and loads of other services that we are working on at labs. I just wanted to give you a few examples, right? That, I think, is where the world is headed. Think about all the work that we have to do today in society, in the different verticals, in healthcare or transportation or whatever. If we could create solutions for each of these problems in the services world to be delivered as a service on the cloud, being accessible in a very easy-to-use way through these billions of touch points, the endpoints that we have, it will make the work of services so much more better. So with that, I want to sort of highlight the 5 solution areas that HP and HP Labs is embracing. And some of the work is actually going on in Jamie's lab, and I think she will go into a lot more detail here today. We heard a lot about healthcare. So let me give you an example of a work that is going on in that healthcare vertical. In our HP labs in Singapore, I know that there are some researchers here from Singapore right here. So one way of monitoring health data is to go to a hospital and get a checkup of your blood pressure or whatever, diabetes shots and so on, right? The other way is to monitor yourself 24/7. So imagine if you have a little device that monitors your heart rate, your blood pressure, all the body symptoms, right? And you have that little device with you, with a very sort of unobtrusive way, measures these body parameters, and it sends it through Bluetooth or whatever to a phone, and it uploads it to a cloud, and essentially all the body parameters are available to the doctor and the patient in a secure manner. So obviously you don't want other people to look at it, right? So that could change healthcare. So it's an example of an HP Labs application in the area of personalized healthcare where doctors and nurses can actually monitor 24/7 data and all on its patient. Now, clearly, there are issues about privacy, issues about control and so on that are being worked on. That those are societal problems and so on. It involves, as Robert said, changes in business models and so on. But here is a way you can transform the healthcare industry. Work going on in transportation. Today, if you look at the transportation industry and you book a flight, and then suppose that flight, you have a weather, a winter storm in Chicago, right? And a lot of flights get canceled in that very, very busy hub. You have to stand in line in a lot of those customer service stations for United and American and so on. That provides a bad experience from a service perspective. If based on that, the fact that here's a bad weather pattern that is going on, if the airlines could automatically change the flight schedules, change all the passenger reservations, and people could see on their cell phones, oh, you were on this flight, you just got changed on this flight, the amount of customer service that you could increase in the transportation industry would be huge. Look at communications media, look at public sector, look at financial services. Essentially, what I would like to do is to ask this group of researchers to work on services problems, entire vertical stacks to be provided as a service on the cloud and delivered through these billions of touch points that we all own. Thank you.